Okay, to expand upon what we have done so far, which is find the GCF and factor out the GCF, we're going to introduce factor by grouping, which is the same thing, just add another step. Actually, what it does, it makes a factor polynomial and turns it into 3 factor out the GCF problems, which we'll see here. So I have this quadrinomial, I have 4 terms, and I'm asking you to factor this entire polynomial. Well, we don't know how to factor 4 terms, so why don't we, step 1, cut this polynomial in half. So I have 2 halves, 2 on each side. Because that's going to help us, because what we do know how to do is to factor out a GCF given 2 terms. So you see here has 2 different problems in one. So like we normally do, I'm looking for my GCF. 12 is broken down into 2 times 2 times 3. X cubed is 3x's. 2x squared is 2 times x times x. And now I'm looking to see what do they have in common. So I have 1, 2, and 2 x's, which means my GCF is 2x squared. That's what I'm going to take out of each of these terms. So looking here, what do I have left over? 2 times 3 is 6, and an x. That's my first. And here, notice I've taken everything out. My GCF was this number. So what happens when you divide a 2x squared by 2x squared? Well, you get a 1. So on the left side, my GCF 2x squared. Once I factor that out, I'm left with 6x plus 1. Now I move on to the right side. Negative 3x minus 5. So looking at negative 3, I have a negative 1 times 3, which is 10, which is 2 times 5. Times x. I'm sorry, 30? Yeah. So 3 times 2 is 6, times 5, 30. And negative 5 is just saying negative 1 times 5. Now what do they have in common? I see that they share being a negative, and they share a 5. So I'm going to take out a negative 5 as my GCF. What do they have left over? I see a 3 times 2, which is 6, and x. And again, notice I've taken out everything. My GCF was a negative 5. So divide it by itself, you get a 1. Now, factor by grouping has a nice checkpoint to check to see, are you on the right track? Have you done it correctly so far? So if you look in parentheses, what do you notice? They are what? Equal. That's a checkpoint to say, hey, you've done it correctly. If they're not equal, go back and check to see if you missed something or if something's wrong. So now that you have that, now that they're equal, we want to bring it all together as one big old polynomial again and look to see parentheses are equal. That is going to be my GCF, right? So as that as my GCF, I'm going to take that out as one factor. And what does that leave? It leaves us with a negative 5 and a 2x squared on the outside, which becomes my other factor. So that big old long polynomial factors into 6x plus 1 times 2x squared minus 5. These are the steps we're going to do to factor by grouping. Now I'm going to show this live. So what was the first step? Split. Cut in half. Factor out the GCF on each side. This left side, what do you think is the GCF?
The variable.
Yeah. The variable m. And how many m's do they share? 2. So I'm going to take out m squared. Taking away 2 from 3 leaves me with just 1m. And what do you get when you divide a negative m squared by m squared?
1.
A 1, or in this case, a negative 1. So the left side looks good. Let's look at the right side. What's the GCF? What do they have in common?
2.
Just a 2. If I take away 2 from 2, all I'm left with is an m, right? And then a negative 2 divided by 2 is negative 1. So did you see that? 2m divided by 2, the 2's will cancel, leaving with just m. Negative 2 over 2 is a negative 1. We're at our checkpoint. Look inside my parentheses. Is this equal? Yeah, I've done it right so far. So now that becomes one of my factors, m minus 1. And my other factor is m squared plus 2, the numbers on the outside. So here it is factored, m minus 1 times m squared plus 2. So notice how it's 1, 2, 3 factor out GCFs in one problem. I really haven't shown you anything new. So let me have you give this a shot, and then we'll come together and see if you got it right. All right, so we're going to cut this down the middle and solve each side. What is my GCF on the left? Yep, they have 2 x's in common, so I'm going to take that out. What's left over? I have a 2 and then just an x. And then here, 5x squared, once I take that x squared away, just leave it with a 5. There's the left side. Now to the right, what was my GCF? It was a 3. So 6 divided by 3 is a 2 with an x, and 15 divided by 3 is a 5. Did you get to the checkpoint and found that these were equal? Very good. Those weren't just equal, they were also part of my factor here. So 2x plus 5, and the outside, x squared plus 3. That's what you should have gotten. Pat yourself on the back if you got there.
X squared.
Yeah, x squared plus 3. What's that?
No, that's it. How'd you get that?
This one?
Yeah.
Okay. So, you know where I got this, right? That's from here. If I take that away, what do I have left?
Just the outside.
X squared. If I take 2x plus 5 away from 3, what do I have left? So it's just the outside. Yep. X squared plus 3.
So you're just doing that the one right there behind the green down, and then x squared plus 3.
Yes.
Okay.
So basically, this is the inside, this is the outside. Notice I'm only writing this once. I'm not putting a square here. That's the GCF. All right, try one more time. Okay, how are we looking? Oops. All right, let's cut this polynomial down the middle.
We're not gonna be using that the 4 in the beginning. I don't think so.
4 in the beginning.
We're not.
So let's see. First off, what's my GCF here?
4 in.
4 in, okay.
Wait. Not
Square? Square?
Yes, square.
That looks better.
Mm-hmm.
4 in squared. So that's what I'm going to take away. 12 divided by 4 is 3. I'm taking away 2 from this 3, so just an n. And then, what happens here? 4n squared divided by 4n squared gives me a 1. And then on this side, does 3n and 1 have anything in common? No, so I'll just leave it as a 3n plus 1. I'm writing it this way, that maybe you can see what invisible numbers out here. They what? And there's a reason why I wrote that. As I'll get to after we do our checkpoint. Equal, right? So that's one of my terms. 3n plus 1. And the other is what's on the outside. 4n squared plus 1. Hopefully put a plus 1 here. It's a common mistake to put 0. Hopefully you went back and maybe saw that that would not have worked out. But yes, there is a 1 that goes here. Because what do you have when you have 3n plus 1 times 1? You have this side. 3n plus 1 times 4n squared, that gives you this side. If you didn't have that, you would be missing this side completely. Okay, that leaves us to factoring. Today we're going to keep it simple. We're going to factor where a is 1, where, what do I mean by a? The number in front of my x squared. So the standard form of writing a quadratic polynomial is ax squared plus bx plus c, where c is your constant, b is the number in front of your x, and a is the number in front of your x squared. So when a is 1, that means I don't have a number here. I'm going to show you a method called the no-fuss method. I'm sure you've seen hundreds of other types of factoring methods. I use this method because it's been proven in my class that this is the best method. I've done all the other methods, and this one is by far how it sounds, the no fuss, the least amount of fuss. So we have a polynomial we want to factor. We know factors look like this with parentheses. Our first step is to write whatever is in front of the square twice, x and x in this case. If it happened to have a number like we'll see tomorrow, then I would write 2x and 2x. Whatever's in front of the square, write it twice. Next, notice I have empty spots. It's waiting for some numbers here. How do you find those numbers? Well, we've taken care of this side, the a, with those first x and x. Now let's look at the other numbers. Looking at the last number, 7. This is what I call my multiply to. I'm looking for two numbers that multiply to this number, and those two numbers also have to add to the middle number. But first, let's look at this, the last number. 7. What times what equals 7? 1 times 7. That works. Now I have to decide, does 1 plus 7 equal 8? It does. So that means 1 and 7 fit right into my spots there. X plus 7 times x plus 1 is what this polynomial factors into. And you're done. When a is greater than 1, as we'll see tomorrow, exact same steps, except for you add another step at the end to where you factor out a GCF. That does show up. Do y'all remember FOIL? How to check to see if this is correct? First, outside, inside, last. Mm-hmm. So first x times the first x gives me x squared. O, outside, so this x and the outside 1, x times 1 is x. And then I stands for the inside numbers, 7 and x. 7 times x is 7x. And then the L is the last. 7 times 1 is 7. And then now combining my like terms, I get x squared plus 8x plus 7. Is that what I originally started with? It is. So that's a way you can check your factors to see if it comes back to the original polynomial. Like I said, factoring is the opposite of distributing, which is what we're doing here. So let's see this step live, the no fuss method. I know that when I factor, it's going to have parentheses like this, right? I just got to fill in the gaps. What do I have in front of my square? Just an x. So I'm going to write x twice. Next, I need some numbers here. I need to make sure those numbers multiply to a 12. 6 times 2 will multiply to 12. But also, I need those numbers to add up to a 4. So how can I manipulate this to where 6 and 2 make 4?
Make 2 negative.
Very good. So 6 plus a negative 2 equals 4. Now, does it also work that 6 times negative 2 equals a negative 12?
Oh, that's good.
It does, right?
Yeah.
So that means plus 6 and minus 2 fills in my holes, and I'm factored. X minus 2 times x plus 6. I am done. Let me show you that one more time because everybody can use more.
How you got the ones with the 2 and the one at the bottom, the one?
What's that?
How you got negative 2?
I need a negative 2. 6 plus a negative 2.
So negative 2 going to the beginning?
Yes. Well, no, it doesn't matter. So x plus 6 times x minus 2. That's fine. It's the same problem. Same polynomial. So no, negative don't have to go to the beginning. Doesn't matter where you put it. X squared plus 2x minus 24. I know it factors like this, right? Parentheses. What goes here? X and x. Now, what numbers am I looking for? Which number is my multiplying number? Well, what number am I looking to multiply? This one, right? You kind of jumped ahead of the gun there. 24, two numbers that multiply 24 is 4 and 6. Can I manipulate this to get a 2? How so?
-4.
Okay, so if I make 4 negative, so 6 plus a -4 is a 2. And 6 times -4 gives me a -24. So,
Wait, you can do that?
what's that?
6 plus -4 equals to 2.
Yes? And then
Okay,
6
okay, I see.
times -4 is -24. So a plus 6 worked with a -2. I'm factored. Those that, some are a lot quicker with the number sense of getting those two numbers than others. That's okay. There is a calculator method. I'll show you later. But right now, I'm letting you struggle with it a little bit. Notice you can just go down the calculator row. 24 divided by 2. 12. 12 won't work. 24 divided by 3, which is what? 8, right? 8 and 3, no, that won't work. 24 divided by 4, 6. Oh, I can manipulate that to get a 2. So just go down the row, you'll eventually run into numbers.
Like the lowest number?
What's that?
It has to be like the lowest number pretty much?
Yeah, well, I mean, only one set of numbers is going to work. So now I'm only going to show this just because it's there. It's floating around out there. Might show up in my math lab. But I don't deal with this too much because I need you to show me that you can factor. Spoiler alert, this doesn't factor. But let's see what happens. 24, let's go through the multiples. 24 and 1. I can't get a -4 out of that, can I? So let's see, 2 and 12. Can you get a -4 out of that? No. 8 and 3. Can you get a 4? Nope. What else was there? 6 and 4. Can you get a 4 out of 6 and 4? No. I think I've used up all my multiples. If that happens, then this polynomial is considered
Not to be factored.
prime. Yeah, cannot be factored is what you'll see as a answer choice. But just FYI, there are some polynomials that you can't factor. They're prime. Don't expect that too much, or as a trick question. So now let me have you give it a shot. Factor this polynomial. Okay, let's see what we got. Should have started with parentheses. At the very least, you should start with that and then put what here? Hey, I would have gave you some partial credit if you just had done that. Now we need to fill it with numbers. These numbers multiply to what? 40. So give me two numbers that multiply to 40. 5 and 8. Sorry, I didn't mean to put an S there. Does 5 and 8 add to 13 somehow? Yeah. So what 5 and 8 gives me a -13? -5 plus -8. I see how that makes a -13. But does a -5 times -8 multiply to a positive 40? Yeah, two negatives makes a positive. So my two numbers are -5 and -8. I'm done. Very good. One more. Factor this. Here we go. Again, you would have gotten some credit if you just put your parentheses and your X right here. Would have gotten even more credit if I seen you attempting to do multiply and add. So 64, 8 times 8 is 64. Do they add to 16? You bet. So I'm going to put a +8 and a +8. And hey, what do you know? This is actually a perfect square that we'll see on Monday that you didn't have to use a formula for. X plus 8 squared.
Because it's 2 times.
Yeah, because it's 2 times. So notice on Monday I'll give you a formula that you can just plug in if you notice it. Otherwise, you can just factor it like normal. You don't have to bother looking at your A and B.